Hey guys, Quentin here from Working Forge Works and Blade Smithing for Beginners. I'm just going to kind of jump right into this. We've had a lot of people asking about making a baskets by hand. Can you do it? Do you need a press? Etc. etc. The short answer is yes, you can do it by hand. I've been doing it for many years. You just have to be willing to put the work in. Obviously, it's going to take a lot longer to draw a billet by hand than with a press or a power hammer, but you can do it. And I know there have been a lot of people lately that have tried and not really had success with fork welding. And in my experience, it comes down to a small handful of things that can go wrong. The first is bad steel prep. And I will use this guy as an example. So this is the billet. This is the billet that I'm going to be using. Okay, I've already tacked everything together. Got a little bit of water on it so I can cool it off, but it is bright, shiny surfaces. Those will weld. However, so this is the side that I've cleaned. If your steel looks like this, if it has rust, if it has mill scale, if it has anything that's not shiny on it, it's going to be in the conclusion. That's not an if, that's going to happen every time. Rust will not weld to good metal, so don't try to weld dirty metal. And the other thing really comes down to how you're prepping this billet. Now, if you look, you can see that I've got 1095 and then two smaller stacks of 15 and 20, so on and so forth. Now, the important thing here is because my 15 and 20 is not an eighth of an inch thick like the other stuff, that it's sandwiched in between the thicker plates. The reason I do this is because if you try to tack weld this with the thin stuff on the outside, it will expand and you'll get big humps and you'll get air and you'll get stuff in there that you just don't want. So yeah, keep the thick steel on the outside. Other than that, the biggest thing is really not enough heat or fluxing at the wrong temperature. Most people will wait until they have a good orange glow to flux. That's wrong. Do not do that. Flux will melt at about 800 degrees, which is pretty much the time that you start seeing any color in your steel at all once it comes out of the forge. So you do not want to flux at an orange heat. If you have, you failed. You're not going to set those welds because at an orange heat, the little bitty gaps in here will start to oxidize and it's not going to stick. So you need to flux at a red heat and then continue to flux, basically. Wait till it gets red, you want just enough to stick, and once you've sealed the outside of this billet with melted flux, then you can go back, let it draw a little bit more heat, add some more flux, and let it seep down into the crevices using capillary action. Basically, it'll suck it into the cracks. You have a good seal, and you're good to go. That is why when you see people welding by hand, which I will be doing shortly, we're waiting on the forge to heat up, and again, I will go over the color when we do the flux and all that. But that's why you see all the crap fly out of the billet. It's not scale, it's not, liquid metal flying everywhere, it is hot flux being forced out of the gaps in your billet. That's what you're looking for. If you're not slinging flux, you probably have an inclusion somewhere, and that's going to be bad. But yeah, we're going to wait for the forge to heat up a little bit more. I'm going to start preheating this billet, and then we will get on to, the techniques of actually using the hammer and getting everything stuck the first time. Another thing I would like to cover is the size of this billet, okay? So this is just what I had on hand at the time. It's not normally what I would use if I'm welding by hand. But as you can see, it's approximately 1 inch tall by 4 inches wide by about 2 inches the other way. Typically, I would start with 1 1/4 inch, 1.5 inch steel at the biggest, but again, this is what I had on hand. It's about 2 pounds of steel. You don't want to try to do anything bigger than this by hand. If you do, it's going to be a monster. Even if you get the weld stuck, you're going to spend a week drawing it out. You don't want to do that. So try to keep it this size or smaller. A really good size to start off with would literally just be 1 inch stock, stacked 1 inch high, and do 1 inch by 1 inch by about 4 inches. That's enough steel to make a blade, and it's more than manageable by hand. So now I'm just rotating the billet. You want to make sure you're getting as even heat as possible when you bring it up to that initial temperature. You don't want the outside to have heat, and inside still be cold enough to not melt the flux. Because again, you do want a complete oxygen barrier for what you're doing now. Honestly, you can skip flux altogether. If you have a little, 1K flux core welder like I have, you can do it like you were going to weld a stainless fillet. You can literally just weld all the way around on the seams. In which case, you don't have to worry about oxygen anyway. Just make sure you stick it the first time and you're good to go. I was taught to use flux, so I use flux. I'm going to keep using flux unless it's stainless. So, again, for demonstration purposes, we're going to use flux. Alright, so this is going to look much hotter than it actually is, just because of the camera. But I've got a good cherry red going on. And we've got just enough heat to start melting flux. So get everything nice and covered. Now I will say, as a disclaimer, I use a lot of flux. So I've got full coverage all the way around, and yes, it will slowly melt and seep in there. But I've got full coverage. This will eat up your forge liner. I don't care, I'll replace it. I would rather have no oxygen and have to replace a brick than nothing at all. But yeah, so we're completely sealed up. I'm gonna go back in the fire. So there's another thing I would like to go over while we're waiting on the billet to heat up. And this is just a way to check if your steel is solid. So this would be still really rough in the works, but it's pattern welding. So we're going to hold it by a string and tap it. That nice clean ring basically tells me that there are no inclusions. And for example, to what it will do if there are inclusions, I'm going to use this piece of cable. I've welded about an inch of the end, the rest of it is just steel cable. But the principle is the same. You get nothing because all of the voids in that cable all the voids in the cable stop sound from traveling. Same thing will hold true to your billets, and you can kind of tell how bad the inclusions are by the sound. So a clear ring like that means you've got a solid piece of steel, it's ringing like a bell. However, if you have partial inclusions, it may ring, it just won't ring as long. So instead of a 4 to 5 second ring with a little tap, you'll get a second, second and a half, and then you may want to look at that. We will go on some other things with the billet, how you can tell if you have inclusions after I set the initial welds as well. Alright, so the steel's about up to temperature, and what we're looking for here, if you're actually looking in the forge, I would try to show you, but the camera's just going to get a white glow. If you're looking for a rapid boil on the flux and a uniform heat all the way through the building, you're looking for really close to white hot. Normally I'd describe it as, a really bright orange. But yeah, you're looking for a rapid boil on the flux and then uniform heat all the way through the billet. Looks like I'm about there. So I'm going to go ahead and pull it out and set the welds with a hand hammer. And what you're looking for here, and it doesn't matter if it's a rounding hammer like this, it doesn't matter if it's a ball beam, a regular sledge, whatever you got, we want to use the flat side though. You want to get flat, even blows. You're not trying to weld into it. You just want nice, uniform, overlapping taps to set the welds. And I'm going to do one side, and because the bottom side of this anvil is going to draw heat from the other side of the billet, I'm basically going to set one side, throw it back in the forge, flip it over, and then reset the other side. Also, at this stage in the game, put your PPE on. Also, if you can see that real well or not, but gloves are optional. Personally, I'd rather burn my finger a little bit and still have the textile dexterity of my fingers than put on big heavy gloves. Personal preference, if you don't want to burn your hands, you should probably wear gloves. So we're good to go, and it's still way too bright for you guys to see. Right now I'm looking at a nice dull orange, but what I'm wanting to show you here is the uniform color. So if you had voids anywhere, you would have spots cooling quicker than others, and you would get like big dark spots up in here and all. And so looking at it, I've got a nice solid shock, but we are going to heat it back up, and I'm going to give it a couple more passes to ensure that we have these welds securely set. So really hope you guys can hear me over everything. But another good thing to keep in mind when you're setting welds like this is don't get impatient. You know, if the color's not right on the second pass, assume it's not welded. You know, assume that you need the same temperature, because you're just trying to make sure everything's nice and tight. And if you try to work it too cold after you've initially set the welds or partially set the welds, you're basically going to split them back open and ruin your billet. So don't do that. I'm going to give it a few more minutes. I just went over there and flipped it again because we were talking about keeping your temperature even all the way through the billet. And now I'm basically just going to go back and do a couple security passes. Just to make sure I know everything is nice and set. Now, once I'm 110% sure that it's set, I'm going to show you my method of testing to make sure the welds are secured, which is pretty simple. You just turn the billet 90 degrees so that your layers are actually facing up and smack it with a hammer. If they come apart, your welds aren't set. If the billet stays solid, you set your welds. It's pretty simple. Like I said, there's really not much to this. The initial welding is probably the easiest part of the process. The hard part, the finesse and all that, that comes later when you get into pattern manipulation and stuff like that. Just knocking the scale off. So again, still too bright for you guys to see, but I've got nice tight lines. Everything appears to be welded well. I'm gonna heat it up again, do one more pass just for safety, and then we're gonna start beating the crap on the side of it. Still a little too bright for you guys to really see anything, unfortunately, but it's nice and solid. There you go. Now you can kind of see a little bit. But it's nice and solid. I got a little bit of scale on the end there. But we have a nice, solid bar. And as I mentioned before, the easiest way to test that, turn it up 90 degrees. And really well on it a little bit. So back to that side, I got nothing opening up. We have a nice solid piece of steel. So I don't have any inclusions currently, but let's say I did have some surface inclusions, right? The easiest way to fix those is to not panic, and you just want to grab a punch. So the best thing pocket. You'll have a nice black round bubble, something like that. Put it in the center of your little black part. Give it a nice lug tap. Go ahead and pop that bubble. Bring it back up to heat, and then you can reflux and basically just push all the flux out of that void. Because 9 times out of 10, if you have prepped your steel properly, you've done everything properly, you flux at the right heat, and you still have an inclusion, it's because you didn't work overlapping passes in your billet. And when I say overlapping passes, what I'm talking about is, you want to hit this area, and then this area, and then this area, and this one. And you want overlapping hammer blows all the way down. And what a lot of people will do is, they'll forget about the middle here, and you'll work your sides, and what you end up doing is trapping flux in the middle, and you get inclusions. Think of it like a tube of toothpaste, right? So you basically want to work from one end to the other, and I'll normally go left, right, left, right, left, right, all the way down, so that we're pushing flux out as we go. That way you get good steel-on-steel contact, and you have nothing to worry about. But I'm going to leave it at that for now. So that's pretty much the basics. It's good prep work and appropriate heats, and anyone can do it. I mean, basic welding is not hard. Anyway, if you guys have any questions, anything like that, just hit me up either here on YouTube or on Bladesmithing for Beginners. I'll put a link to it below. Just hit me up with direct questions, anything I didn't cover, anything you would like me to cover in the next video, pretty much just anything. And I'll leave it at that and go ahead and shut everything down. Thank you guys for watching.